there with our liquid level gauges, and flow gauges can also be tied into this group because they function on the same basic design. So the liquid level gauge is used for a few reasons on the transformer. It's obviously to detect a low oil level, which can, if it gets low enough, it can result in catastrophic failure. And it's also used for filling the transformer and things of that nature. Most of the time, the switch contacts are at the low setting on the liquid level gauge to indicate a low oil level. And we have some videos here for testing to kind of simulate it, or to show you how easy it really is. So testing a liquid level gauge or a flow gauge, all you really need to do is remove the case from the flange. So most of the time there will be 4 set screws on the side of the case. So what you see here is the case portion of the liquid level gauge. They're magnetically coupled, so magnetically driven. So all you need to do is remove the front case, and then use any magnet, and you can place that right on the center back of the drive shaft of the liquid level gauge, and you can actually move the pointer and actuate the switches. So here you can see there's the first low switch and there's the second low switch. And all I'm doing is twisting that magnet on the back. And that gives a good simulation of the actual drive mechanism moving inside the tank. And then the same on the 3.5-inch liquid level gauges as well. So one thing to note with the liquid level gauges is that the part of the gauge that takes the most environmental wear and that's out and exposed is the case. So the flange is covered up by the case on the outside of the tank, and then the rest of the flange is internal, which is most of the time submerged in oil. So doing a full functionality test on the flange itself, most of the time it isn't accessible or necessary. And for how simple it is to test the liquid level gauge, most of the time this is a great way to see if those contacts are still working and they're functioning at the levels where you think they are and where you want them to be. So we can move on to our remote temperature gauges. This first test here on the left only applies to remote temperature gauges that we offer. Our smaller direct mount, you cannot do the same type of test. I just want to make that clear up front. It could cause some damage on direct mount, but with remote mount, this test is fine here. So remote temperature gauges are used for obviously oil temperature and winding temperature, top oil and winding temperature. And these can also be used for alarms or cooling stages, turning on your cooling fans, pumps, your whole cooling system. So you really want those switches to be working and know that they're working. So testing our remote temperature gauge. So this here on the left is our 104 and TR6000 family. It's also nearly as simple, if not simpler, than the liquid level gauge. All it requires is to remove the front bezel, remove the front lens, and then you can actually push the pointer up the dial to actuate each switch. And this won't cause any harm to the gauge at all, as long as you don't push it down from where the temperature range is currently sitting. So right in this video, we're right at about 25 C. So I'm just letting that glide down the dial range because it is spring loaded, and it'll return back to that original place. But it's no problem to push it up the dial range and actuate those switches. And that's a real quick and easy way to test that all those switches are functioning and that they're actually going off at the desired temperature. Another quick and easy field test, which you can see on the right here, to test actual functionality of the thermometer itself, is just an ice bath test. And what this does is, once you put it in the ice bath, it's going to zero out. You want it to zero out. And if it doesn't, that can lead to other issues, like say there's a leak in the capillary, because this is a high pressure capillary system. There could be a leak. The preload, there could be an issue with that on the gauge. So you really want that to zero out, and that's a good quick way to do a functionality test. You could pull that probe out of the well, put it in a cup of ice water, and watch the gauge go down to zero. So these are two easy field tests that can be done on the 104 or TR6000 that we offer. This ice bath test can also be done on direct mount bimetal thermometers. Pushing the pointer cannot be done on those. So let's move on to our pressure relief devices. So here specifically, we're going to be talking about our large pressure relief device and our extra pressure relief device, which are LPRD, XPRD, sometimes the 208 or 213. So full functionality testing of the pressure relief device is very difficult in the field. You would need to have a tank that you could pressurize to the relief pressure to simulate a blow-off of the pressure relief device. But testing the switch is very simple on both of these. And the reason you want to test the switch, because that's typically the most common failure point on these. You're not going to have excessive wear on the springs or seals internally on the pressure relief device. The switch is what is out in the environment. It takes the brunt of the damage and wear and tear. So it's best to test those on a regular basis too. So we can see here video of the LPRD testing. The majority of our LPRD switches have this test lever here. So on the right, you can see the test lever, and on the left, you can see the reset lever. So what you're going to want to do is pull the test lever until you hear the switch click into place, and you can see it actuating up the top here. And then you can just reset it with the reset lever. And if your LPRD switch does not have a test lever or a reset lever, this same test can be done with a screwdriver. And underneath here, you'll be able to see the little cam gear that rests on the relief plate of the pressure relief device. And you can actuate that and then reset it with a screwdriver and do the same test. Testing our XPRD is just as easy. So here are a couple of pictures of an XPRD. This is the top of the XPRD, and you can see the switch on the right side here. So in the normal state, the switch plunger is in this little recess on the indicator of the XPRD. And to test the XPRD, all you need to do is pull the indicator directly up. Be careful not to bend it, and pull it directly up, and that will actuate the switch. And that'll simulate this XPRD actuating and pushing this indicator up. So those are two quick field ways to test our pressure relief devices that we offer, both the LPRD and the XPRD. Moving on to our sudden pressure relay, this would be our Qualitrol 900 or 910 RPRR, typically called. And for field testing of these, this is a full functionality field test. It tests the function of the RPRR itself and the switch function. And to do this, we have a field test kit, which is our Kit 013. It's a portable field test kit that can be used to simulate an actual sudden pressure rise in the transformer tank. So this video here is a quick little snip out of a full-length video we actually have on our website. So what this test kit does is you will hook it up to the vent port on the rapid pressurized relay, and you will simulate a sudden pressure rise in the tank by applying pressure to the top of the two chambers in the rapid pressurized relay. So they're separated by a bellows system. So if you increase pressure on the top of the system, it will equal out and it will be back in a normal state. So what we do with the kit is that we apply pressure on the top, let the bellows level out and go back to a normal state, and then we quickly relieve the pressure from the top, which will simulate a sudden pressure on the bottom, driving the bellows into the switch and actuating that switch. So you can see that here in the video. So just to reiterate a little bit, so you're applying pressure on top of the bellows system, waiting for that to level out, and then you're relieving that pressure quickly on top, which simulates a sudden pressure on the bottom or in the tank. And this can all be done with our field test kit. And with increasing regulations, we actually have, there's actually a NERC requirement that requires the testing of sudden pressure relays, mechanical sudden pressure relays every 6 years, which this falls into that category. And our field test kit makes it really easy to do so. And last but not least, we're going to look at the seal-in relay that we offer. Seal-in relay is designed to take in a momentary switch contact and seal that signal in for alarming or trip function. So these are typically paired with our rapid pressurized relays because those are a momentary action, a momentary switch action. When the sudden pressure rises, it actuates that switch, and then the RPR will settle back down, or the pressure will be relieved through some other means. And then you want to keep that alarm or trip signal because that was a serious event that occurred. And that's what this seal-in relay comes in handy for. And we often get questions on how to test these and make sure that they're functioning properly in the field. And that is also incredibly easy, similar to the past products that we've looked at. So with the 909-300, which is the most current model we offer, the 909-200 is the previous model, which is now obsolete. Testing the 909-300 is very simple. What you're going to do is lift the signal from the input, which is pins 1, 2, and 3 on the 909-300. So say you have an RPR hooked up to it, you want to disconnect that, and all you do is jump pins 1 and 3. And this will simulate a contact closing on those terminals, and which will give you your trip function. And this same simple test can be done on the 909-200, but instead of jumping terminals 1 and 3, you want to jump pins 1 and 12. And you don't want to mix those up between the two models, so be sure to check which model you have before performing this test.